Hi, today we're going to be solving the equation 3 secant squared x minus 5 secant x minus 2 equal to 0. Now on this side of the equal sign, the equation is like a quadratic formula, but it's still a bit too complicated for us to factor because of the secants. So we're going to make life a little easier. We're going to let x represent secant x. So we're going to use substitution. So now we're going to rewrite our equation as 3x squared minus 5x minus 2 equals 0. Now the equation looks a lot simpler for us to factor. So the product would be 3 times negative 2, giving us negative 6, and our sum would therefore be negative 5. The two numbers needed to factor this equation will be negative 6 and 1, which we're going to distribute into our equation, giving us 3x squared minus 6x plus x minus 2 equals 0. To start off with, we'll focus on this part of the equation, factoring out 3x, giving us in the brackets x and minus 2, close bracket. We'll transfer down the plus sign, and we'll focus on this part, factoring out 1, giving us in brackets x minus 2 equals 0. So the first one of our brackets, from looking at the equation, is going to be x minus 2, close bracket. The other one will be 3x plus 1 equals 0, as that is what was left over. Since we have a product equal to 0, we're going to break it up into two cases and solve each of them separately, which will give us x minus 2 equals 0 and 3x plus 1 equals 0, which we will then solve as two separate equations. Now we're going to resubstitute secant x back into the equation, giving us secant x minus 2 equals 0 and 3 secant x plus 1 equals to 0. So we have our secant x minus 2 equals 0 and our 3 secant x plus 1 equal to 0. And we're going to start off by isolating secant x by adding 2 to each side of the equal sign, giving us secant x equal 2. But as we cannot solve this part using special triangles, we're going to use a reciprocal identity, stating that secant x is equal to 1 over cosine x, which will give us 1 over cosine x is equal to 2, and invert both sides, giving us cosine x equal to 1 over 2. Now for the other side, we're going to isolate secant x by taking away 1 from each side of the equal sign and dividing both sides by 3. Giving us secant x equal negative 1 over 3. Once again, we're going to use our reciprocal identity, giving us 1 over cosine x equal to negative 1 over 3. Then we're going to invert both sides. It's giving us cosine x is equal to negative 3. Since the cosine has a range of negative 1 to 1, the cosine will never take an output of negative 3, and therefore there are no solutions to this part of the equation. To solve the other half of our equation, cosine x equals 1 over 2, we're going to have to use one of our special triangles. 60 degrees, 30 degrees, right angle, square root of 3, 1, and 2. According to the rules of SOHCAHTOA, we can see that to find cosine, we're going to have to find adjacent over the hypotenuse, which is what gives us the 1 over 2, but it's also positive, which is where we need to use our unit circle. So from looking at our unit circle and thinking about all students take calculus, it becomes clear where the product of cosine will be positive, which will be in the first and the fourth quadrant. So we draw 60 degrees off the reference line, or x, and 60 degrees of the fourth quadrant off the reference line. The radians needed to reach this point in our unit circle will give us our first answer, which will be pi over 3. The reason for this is that 180 degrees is pi, therefore 60 degrees will have to be 1/3 of pi, or pi over 3. And so now I'll need 1, 2, 3, 4, 5. 5 pi over 3. And this will be our second and final answer, 5 pi over 3, since our first answer gave no solutions. So our answer is pi over 3 or 5 pi over 3. Thank you for watching. I hope I gave a good explanation on how to solve this trig equation.